Very good evening, students. Today, I'm going to continuing my last lecture on structure. In my last lecture, I discussed how we can pass a structure to a function. We already introduced the pointer with structure. One topic that is left so far is self-referencing structure. Before starting the discussion regarding self-referencing structure, I introduce a data structure which is completely new to you. The name of the data structure is linked list. And the next semester, in your syllabi, you have the subject data structure. And in that subject, you will learn this data structure linked list in detail. But this time, when I'm going to discuss about the topic self-referencing structure, I must have to introduce this data structure linked list in very brief manner that I'm trying to do so. So let me share a screen with you. I hope the screen is visible. Here, I have drawn a data structure named linked list. And if you want to know the formal definition of linked list, I can define a linked list in this manner, that linked list is an ordered set of data elements. Once again, I am repeating, linked list is an ordered set of data elements, each containing a link to its successor and sometimes its predecessor. So it is not like an array. In case of array, what we know the definition, the array elements are stored in contiguous memory location. But in case of linked list, the data elements are not stored in contiguous memory location. Like array, it is an ordered set of data elements, yes, and each containing a link to its successor and sometimes its predecessor. Here the diagram that I have drawn over here, only successor is linked with its previous node. Try to understand what node is. A node is represented by this form. Look, where it must have at least two space, or better to say two room. A node is represented, if you pictorially represented a node, it looks like this. It's a rectangular box where it has at least two room. At least I am telling, because it may have more than two room also. Fine. When I'm talking about at least two room, that means it has to have at least two room. Among these two rooms, one room is used for storing the data. What the data part of over here, say 100, 200, 300, 400. These are the data parts of the node. And the another part which I am talking about as another room, that is used to store the address of next node. Sometimes linked list is represented in this manner, where the address of next node is stored as well as address of previous node is also stored. That type of linked list is known as doubly linked list. That I'll not discuss over here because I'm just introducing the concept of self-referencing structure. The concept self-referencing structure is used in linked list. In practical implementation, we normally use it in linked list. That's why I just introduced what linked list is. In detail, you will learn chapter linked list in the next semester in the paper data structure. So what linked list is? It is basically a representation of an ordered set of data elements, each containing a link to its successor that I followed over here. Sometimes it links to its predecessor also that I have not followed over here. So each of this element of this list is known as node. And each node, what I mentioned, each node has at least two rooms or two parts. One part is used to store the data elements, this part, this part, this part, this part. And another room is used to store the address of next node. Try to understand, I am talking, it is storing the address of next node. Not I am telling that it is storing the address of next data. No, it is storing the address of next node. What node means? The entire box, data part as well as address part. So when I am representing this in a form of a picture or a form of a figure, note it down, the arrow starts from here, from this box, but it ends not inside this data part. It's outside of the data part. Why? Because it is pointing to the entire node, not the data part only. This is the data part and this is the address part. So when a list is there, that means your first node, this is my first node, that should be pointed by some pointer variable. And I consider the name of the pointer variable as start, which has no data part, but which is only stored the address of first node. Start is not a node I consider. Start is nothing but a pointer which is storing the address of first node. Because before the first node, there is no node there to store the address of the first node. So that's why what I'm doing, I consider a pointer variable like start, which is basically used to store the address of first node. And similar manner, when I'm talking about the last node, there is no node after the last node which is used to point, which is required to point. Fine. So that's why the next part, rather the address part of the last node. So address part of the last node will be null. Address part of the last node will be null. So I hope you understood what is the meaning of start, what is the meaning of this null. This is represented as null, fine, because there is no node after the last node which needs to point. So these are the data parts, 100, 200, 300, 400. And similarly, the start is used to store the address of first node, and for the last node, the next part is null because no more node is there to point. So I hope this pictorial, rather this figure, is clear to you. Fine. So now my next question, very common question from your end also, how we can implement this node concept in program. So when I am trying to implement this node in a program, think about it, think about for a single node, there is a one data part and another part is the address. So you may store integer, float, character, whatever data you want to store, you can store it inside this place. So according to your requirement, you must have to provide the data type of the data part. Here I stored integer. So I consider I am used to linked list to store the integer over here. But for the next part, the part which is storing the address of the next node, what will be the data type of that? First of all, this part is storing the address of the next node. That means it shouldn't be a normal variable, because from earlier knowledge, we came to know that to store the address of any variable or any array or any structure, in all the cases, we require a pointer variable, right? We require a pointer variable to store the address. So here also the same case. If I want to store the address of next node, normal variable is not sufficient to store it, because we are going to store the address of another node. So definitely we require a pointer variable. Next question, what is the data type of the pointer variable? If I write int star ptr, that means ptr is a pointer variable which must store the address of another integer variable. But what address it is storing? It is storing the address of next node. So definitely I am asking the next question, what is the data type of next node? Your answer would be struct node. Am I clear to you? Once again, I am repeating. This address part is storing the address of next node. This address part is storing the address of next node. This address part is storing the address of next node. Fine. So when it is storing the address of next node, definitely it requires a pointer variable. So this part is a normal integer variable because I am storing integer value over here. But if for the second part in my example, I must require a pointer variable because this part is storing the address. Address of whom? Address of a next node. So what is the data type of that pointer variable? When I'm going to declare the pointer variable, I must have to mention the data type about the pointer variable. So what data type it would be? The answer is definitely the node type. What is the node type? The node type is struct node. So that's why the structured definition that I am providing over here, is look like this. Try to understand. Struct node is my structure name. Struct keyword already introduced to you. Node is the tag name. First member is in data, which is used to store the data part. Here I want to store the integer value. That's why I declared it int data. And the second part that I am talking about, that I am trying to highlight over here, it's storing the address of the next node. So definitely I must have to take a pointer variable. I give the name of the variable as next. So name of the pointer variable I consider over here is next. And what is the data type about that pointer variable? It should be struct node. Why it should be struct node? Because this next pointer is storing the address of next node. What is the data type of node? Struct node. So that's why I declared the next pointer in this manner, struct node star next. And as per the syntax of the declaration syntax of a structure, we must have to provide a semicolon at the end of structured declaration. I hope this is clear to you. And this pointer This type of declaration is called self-referencing structure. Why it is called self-referencing structure? Because it is pointing to a variable which is of own type, which of its own type. That's why this is called self-referencing structure. Once again, I am repeating here, the data part is storing the data part of the node, whereas it is when it is I'm declaring a pointer variable that is next over here, it is storing the address of another node, and the data type of this node is struct node. Try to understand, data type of this node is struct node. So that's why this type of structure is known as self-referencing structure, because it is pointing to a structure which its own type. So I hope this declaration is clear to you. Now I am just discuss a programming implementation of this linked list, not the entire linked list. I will discuss very introductory part of this linked list so that you can get a brief idea regarding this. I will just create this list in program and I will just display the content of the list. This much only I will do. I'm trying to do in my next programming implementation. Fine. So definitely the the list is created, rather memory allocation will be done at the runtime, because this is the advantage of the linked list over an array. Because in terms of array, in case of array, we must have to declare the size. We must have to provide the size of an array, and at the time of compilation, the memory allocation will be done. But in case of linked list, it is advantageous because with respect to memory allocation purpose, we will allocate the memory of the node at the runtime if it is required. If we want to store more data, we definitely create a node. That is our task. If we not required to store any more data, definitely we will not create any further node. So that's why the creation of this node is basically it's done in the program execution time, better to say in runtime. So it's an advantage of using linked list over an array. So let me share the programming window with you. I'm trying to write a program of just a create list and the display list of this linked list. And I will do it in a menu-driven programming manner. Fine. So let me declare the structure. The structure name I have given as node. Fine. Struct node. The data part and another one is the address part. So struct node star next. Fine. And this is the declaration part is over of this linked list. Then I will provide two functions. One is create list. So now I will just write this in the direct inside main function, not incorporating function over here. You may write in using function also, but that will do it your own. Fine. I'm directly writing the code inside main. Fine. So first one is creating my list. When I'm going to create the list, the list, so it is basically creating a node at the beginning of the list or at the end of the list. Once again, I'm repeating this line so that you can understand. When you are going to create a list, rather linked list, what you are doing actually, you are creating, you are rather adding a node at the end, or you may add a node at the beginning. Any one option you may choose. So I will choose the option adding node at the end of the list. Fine. So when I'm creating a node, so definitely I would create the node in the runtime. Fine. And what is the syntax of this? Malloc one into, no need to mention, 1 into size of node. Fine. And we need to typecast that node definitely of node start type, and that must be stored inside new node. I've already declared what is new node. So I'm creating a node by using the syntax malloc size of node. And if the node creation is successful, if the node creation is successful, so definitely this new node will store the address of this newly created node. At the same time, what I have done, I consider a pointer variable of type struct node. The name of the pointer variable I given as start, and start initialized to null. Start initialized to null. What it means? It means I will initially, the list is empty. So that means the start points nothing. So that the value of the pointer, or the start pointer, is initially null. Fine. So after creation of this node, if the value of this start is equal to null, then I must have to assign this new node to start. Else means, sorry, one more thing I must have to do before doing this. I have to prepare the node. The node is created, fine. Then printf, I have to take input for the data part of this node. So printf /n, enter the data of the node. Scanf %d, comma, ampersand, new node. This I already You already know to access data member using pointer, we must have to use arrow instead of dot. So new node arrow data, not that data. Fine. And I'm setting the new node next part as initially null. Why I'm setting this initially null? Because I'm creating the list at the start of the writing program. I mentioned I'm going to create the list by appending a new node at the end of the list. So obviously the next part of the last node, when I'm appending as a last node of this new node, definitely the next part of this new node would be null. So that's why I'm setting this next part of this new node as null. So if start value is null, then what I will do, if start value is null, what I will do, I will assign this new node to the start. That means no node currently you have in the list. If it is not null, that means the else part. So that means already some node is in your list. Try to understand. Already some node in your list. Suppose, again I'm sharing my earlier screen. Suppose you have already 100 and 200. Now you are going to append this 300. So what do you have to do? You have to reach at the end of this 200, right now? So how can you identify that is the end of this 200? When 200 is your last element of the list, that means the next part of the 200 will be null. So you have to traverse. You have to traverse the entire list. So when you traverse the entire list, you cannot change the value of start. Why you cannot change the value of start? Because I've already mentioned start is used to store the address of first node. If you change the value of start, your first node address will get lost and you cannot find the starting point of your list. So I cannot modify, I cannot update the value of the start. So that's why I consider in my program another temporary pointer, that is temp, to temporarily store the address of start. And because why I'm temporarily storing the start address, because I need to change the start to traverse the entire list. And in the very next line, I must write while temp next not equal to null, then I have to move temp to the next node by this syntax, temp equal to temp next. So when the temp next value gets null, that means I've temp reached at the end of the list. So I will add this new node as a temp next. I hope you understood what I try to say through this code. Once again, I am repeating. Here I have created a new node. Fine. I have taken input the data part of this new node and I set the next part of this new node as null. Why I set the next part of the new node as null? That I already explained, because I take the approach, I choose the approach to add new node at the end of the list for creation of my new list. Very nice. So this is the code that I'm going to write. It is basically we are creating a list, and after creation we'll display that list. The approach is we are basically adding a new node at the end of the list, the creation approach. So when the list is empty, that means when you are going to insert the first node in the list, your start value will definitely be null. because start points nothing. No node currently is in your list. So if the start value is null, I'm telling you assign your new node to the start. That is written inside this if block. If the start value is not null, that means already you have some node in your list. You may have one node, you may have two node, three node, four node, five node. So you may have n number of nodes. So in that case, what you have to do, you must have to reach at the end of the list, of the existing list. You must have to reach the end of your existing list, and you have to add a new node at the end of this current existing list, or rather current node, current list. So my next question, how can I reach at the end of this list? I have to traverse the list. How can I traverse? I have to move this start from first to second, second to third, third to fourth, fourth to fifth in this manner. But the problem is, if I change the value of start, I will lose the starting of my list. So that's why I will not change the value of start. What I will do, I take a temporary pointer, that is temp. I store the start inside temp, and I move the temp from first to second, second to third. How we can move? This is the code, temp equal to temp next. Temp gets updated till temp next value will not null. If temp next value null, that will stop over there. When temp next become null, when you are at the last node. When temp is at the last node, then only the next part of the temp value will be null. So that's why I have to move this temp from first to second, second to third, third to fourth, fourth to fifth by writing the code temp equal to temp next. I hope you understood. And after reaching at the end of the node, end of the list, I am just adding my new node as a temp next. So temp next equal to new node. Temp next equal to new node. So definitely this part of this code must be iterate for n nodes. That many number of node I want to add in the list must iterate this part. So what I can do, I can write it in a form of a function that I want to do earlier. So just write void create list, fine. Create list, name of the function I'm giving. And another function is the void display. Fine, no need to pass any parameter, because what I will do, I will declare this start equal to null in the global plus. Start is the starting point of your list. It holds the starting address of the first node. So if I declare this variable in the global places, that means no need to pass this to any function. So trying to define, so I'm omitting this part from here. So trying to define void create list, fine. And I must have to copy this code, and it must be the function definition of this, fine. And inside main, what I will do, I will just give the option printf 1/n1. create list, and second option is, say it is display. Then what I will do, printf menu driven program I try to write. So enter choice. This part must be written inside loop. Enter choice. Then give one more option, exit, so that I can come out from this loop. Exit /n 3 exit. Fine. So this part I must have to write inside loop, say while one. So infinite loop. By choosing option 3, we can come out from this loop. Fine. Enter choice. Scanf. %d ampersand ch. Then switch ch. Case 1. Create list. I have to call the function create list from here. Fine. Similarly, break for case 2. I have to call the function display. And for case 3, I have to call the function exit. It takes an integer, so exit 1. And the default is exit terminates the program. So that's why no need to give a break statement after exit. If you give anything else except 1, 2, 3, so it will display. It's a wrong choice. Fine. So declare a variable int ch that I haven't declared. So this is the structure of a menu driven program. Case 1 for create list, case 2 for display, and case 3 for exit. Fine. This is the create list. If the function called create list, node will be created. I have to give the data part, set the address part as null. If start equal to null, start should be your new node. Else I have to traverse the entire list, existing list by this approach, temp equal to start, while temp next not equal to null, temp equal to temp next, and temp next equal to your new node. Next question, next function I need to define over here, that is void display function. So again, I have to do the traverse. Fine. Thing is bit similar, just the else part of the previous function, but bit different. It's not exactly same. Why not exactly same? Because when I'm printing the element of this linked list, try to understand, when I'm going to print the elements or data elements of this list, I have to print 100, 200, 300, 400 also. But when I'm trying to reach at the end of this list, I have to stop when I am in 400. Because I set the condition when temp next equal to null, I must come out from this loop. So if I use the same condition over here, the 400 will not be printed. I mean, once again, I'm repeating. Temp equal to start while temp next not equal to null. Temp next null, answer is no. So temp move from first to second. Temp next null, answer is no. Temp move from second to third. Temp next null, no. So temp move from third to fourth. Temp next null, yes. So if temp next null, it will not enter into the loop body. So I cannot print 400 over here if I put the condition while temp next not equal to null. So I have to change bit changes required to traverse the entire loop. So let me show you the code, what I have to write. In the same manner, I have to declare a temp struct node start temp, fine. Temp equal to start, fine. While temp not equal to null. Here I must not write temp next not equal to null. I must have to write temp not equal to null. Then what I will do, print %d arrow, print an arrow, fine. Then what I will print over here, temp data, fine. Then I will move temp to the next node, temp equal to temp next, just like earlier, fine. And when I am coming out from this loop, I just print a null. Try to understand the difference between temp next not equal to null and temp not equal to null. Once again, I am repeating this part. When I am writing temp next not equal to null, that means when I am at the 400, I cannot enter inside the loop, fine, because temp next is null. But when I am writing temp not equal to null, the value of temp is not null now. When temp is pointing 400 node, the value of temp is not null now. So it enters into the loop, it prints 400, temp will now change to the value temp equal to temp next. What is the temp next value is now? Null. So now the temp value becomes null. And when it re-enters into the, tries to re-enter into the loop, the condition fails because now the temp value is null. So difference between temp next not equal to null and temp not equal to null, I hope you understood. When temp next not equal to null, your traversing reached at the end node, but you haven't crossed the end node. When you are writing temp not equal to null, that means you have already crossed your last node. So when I am trying to display the content of each and every node, I must have to process each and every node separately. Fine. So that's why I must have to put the condition temp not equal to null instead of temp next not equal to null. Fine. So let me execute the program. Compile and run. So error comes. Let me rectify the errors. It is not node star, it is struct node star. Very sorry. Fine. Sorry, it is not node only, it is struct node. Very sorry. Struct node. Fine. Expected declaration statement of end input. Not getting what is the meaning of this. line number 63. Okay, so it's a error. It's a error. So there is a error in closing of this while loop. Fine. Now it is given. Forgot to give the closing of while loop. I hope now it will execute fine. Let me check once again. Yes, it starts its execution. Let me share the output screen with you. So enter create list is my first option. So I'm giving choice 1. Enter the data, say I'm putting 100, first data. Again, I'm creating my list. Second data, it is 200. Again, I'm creating the list. Third data is say 300. So third data I have given, entered the data, it is 3, fine. So again, I am creating list, choosing option 1. So it is 400, say, fine. Now I'm trying to display, look, 100, 200, 3, 400, and finally I have print a null. Of giving the option 3, it must come out from the program. So I hope this much is clear to you. Fine. So this is the implementation of self-referencing structure, which is very much important for implementation of linked list. You must go through this topic in detail in the next course. So this is the implementation of self-referencing structure. One more topic I must mention before completion of this chapter, structure. The name of the topic is union. No such big use for today's programming language, but there is a concept union bit similar to like structure, but it is not actually similar to the structure. There is some difference, but the declaration syntax and accessing member variables all are similar to this, all are almost same to the structured declaration. And like structured declaration, it is a derived data type. But the difference between the structure and the union, the point I must have to highlight is union, the member of this union shares the same storage space. Once again, I am repeating, what is the difference? The difference between a structure and a union, this point I must have to highlight. The members shared the same storage space. And the members of a union can be of any type. And the number of bytes used to store union must be at least enough to hold the largest member. So like structure, a union may consist more than one data members. Who are the members? Like my student example, the structure member variables are ID, name, address, phone number. These are the members of the structure declaration. Similarly, when we going to declare a new union, let me write a small program to introduce union with you. So instead of struct, I must have to write union. Tag name, say I'm giving test is the tag name. And like structure, union can have also more than one data members. But what is the difference between this structure and union? That needs to be highlighted. The data member of this union, what is the data members of this union? A, B, C. These are the data members. And if it is not an union, if it is a structure, what is the size of, what will be the size of a structure variable? Like structure variable, we can also declare a union variable here. So what is the size of this structure variable X if it is a structure? So it would be definitely 4 plus 4 plus 1, total 9 bytes. But when I am talking about it is a union, the union data members share, I just mentioned the union data members shares. Let me share the screen with you, programming screen. Forgot to share. I've written a code. Yes. So like structure, I declared a union variable. The keyword I must have to use over union instead of struct. These are the data members, just like structure variable. What is the difference between the structure and union? I just mentioned that data members share the same storage space, and definitely a union variable must be at least enough to hold the largest member. So what will be the size of this union variable? Here I declared a union variable X. The size of the union variable should be only 4, not 9. Why it is only 4? Because here the highest data type size is float. So the union variable size is 4. And each data member A, B, and C are using that 4 bytes. So now your next question definitely is, how then A, B, C all can store the data inside this 4 byte? Because the summation of this all 3 data member is 4 plus 4 plus 1, total 9 bytes. But if the union variable size X is 4 byte, how these 3 data members can store their data simultaneously inside this 4 byte? Answer will be no. They are not storing all these 3 data members at the same time in this space. That's why I just mentioned the line. Union variable shares the same storage space. That is, each and every data members individually sharing that same storage space. So when I'm storing A inside 4 bytes, B and C cannot store. After working with the variable, or rather working with the data member A, we can store the variable B, because when I am storing the variable B in the same storage space, the data, rather the value of the A data member gets overridden by the variable B. And when I am storing the value of C, because they are sharing the same storage space, the value of B get lost when I'm storing the value C inside that same storage space. That is the big difference between a structure variable on an union variable. And normally in today's programming, we will not use this union preferably, though the size of the union variable is much lesser than the structure variable, but we cannot use all the data members at the same time. We cannot store all the data members at the same time under a single variable name. That is the limitations of this union variable. So I hope you understood what is the difference between the structure and union. Regarding union, this much is enough. We need not to know further because we don't have much use of this topic union, but we must have to know what union is and how union differentiates with the structure. So I hope this much is clear to you. Thank you. Thank you very much once again.